Okay, so you want to own an aircraft boneyard and part-out facility. You picture yourself buying retired commercial airliners for pennies on the dollar, parking them under the blistering desert sun, taking a blowtorch and a wrench to the fuselage, and selling jet engines and flight instruments to desperate airlines for millions of cash while you sit in an air-conditioned trailer counting your profits. That is the fantasy. Here is the reality. The global commercial aviation aftermarket is a $90 billion industry, with the market for used serviceable material, or USM, accounting for over $10 billion annually and growing faster than the supply of new aircraft itself. Companies like GA Telesis and AAR Corp generate billions of dollars across their aviation supply chains, dismantling hundreds of retired airliners every single year to feed an insatiable global demand for replacement parts. A single pair of high-bypass turbofan engines stripped off a 20-year-old Boeing 737 can trade for $6 million cash in less than 48 hours, which is more than the entire gross domestic product of several small island nations combined. Yet, here is the paradox that crushes 90% of outsiders who try to buy their way into aviation recycling. An airplane is not valuable because of the metal it is made of, and it is certainly not valuable as a parked machine. A retired commercial airliner is only worth money if every single component, from a $3 million turbine rotor down to a $500 hydraulic valve, comes with an unbroken, legally unassailable paper trail tracing its operational history back to the minute it left the factory floor. If you lose one folder of logbooks, or if an FAA inspector finds a 6-month gap in an engine's historical maintenance records, that $3 million turbine instantly turns into $25,000 of raw scrap nickel. Understand FAA Form 8130-3 traceability and the brutal economics of engine green time, and you understand this business. Miss them, and you will go bankrupt owning one of the most expensive, highly regulated parking lots in the middle of the desert. To understand why this industry is booming right now, you have to look at the structural crisis gripping the commercial aviation sector in 2026. For the past several years, the world's major aircraft manufacturers have faced historic manufacturing bottlenecks, supply chain breakdowns, and regulatory delivery delays. Airlines that plan to retire their older fleets of Boeing 737 Next Generation and Airbus A320 aircraft have been forced to keep those aging jets in the air to meet record passenger demand. When an airline flies an older aircraft, that plane requires significantly more maintenance. But because new original equipment manufacturer parts from companies like Boeing, Airbus, and Pratt & Whitney have lead times extending 12 to 18 months, airlines cannot afford to wait. Every single hour that a commercial airliner sits on the tarmac grounded for maintenance, an event known in the industry as an AOG, or aircraft on ground, the airline burns between $10,000 and $150,000 in lost revenue, passenger rebooking fees, and gate penalties. You probably think your customer is a scrapyard broker looking for industrial aluminum, but your real customer is a vice president of supply chain at a major airline or a massive maintenance, repair, and overhaul facility who has a jet stuck at an airport in London or Tokyo with a blown hydraulic actuator. They do not care about saving 10%. They care about buying an authenticated, flight-ready replacement component with certified logbooks delivered to their gate within 6 hours. You are not a junkyard operator. You are an emergency liquidity provider for the global aerospace transport network. This demand is structurally protected because the commercial aviation fleet is locked into mandatory maintenance intervals mandated by international law. An airline cannot simply choose to delay an engine overhaul or a landing gear replacement because the economy is in a recession. When a component reaches its flight hour or cycle limit, it must be replaced immediately. If a new part is unavailable or costs 4 times as much, the airline has only one legal alternative: buying certified, used, serviceable material from a tear-down facility. However, before you go bidding on retired airplanes at auctions, you have to understand that this industry is split into distinct business models, each carrying radically different capital requirements, margins, and risk profiles. The first model is pure storage and preservation. In this segment, you own or lease an expansive airport ramp or desert taxiway, and you charge airlines, banks, and aircraft leasing companies a monthly fee to park and preserve their dormant airliners. You provide routine maintenance, wrapping engines in protective covers, rotating tires, running auxiliary power units, and keeping humidity out of the avionics bays. This model requires lower startup equipment capital, generates predictable recurring monthly income of $2,000 to $5,000 per aircraft, and yields healthy net margins of 20 to 30%. But your upside is completely capped by your square footage of tarmac, and your revenue drops whenever airlines pull planes back into active service. The second model is teardown as a service, or contract part out. In this setup, an aircraft leasing company or an airline owns the retired jet, and they hire your facility to dismantle it on their behalf. You defuel the plane, strip the engines, pull the avionics, remove the flight controls, and slice up the remaining hull for a flat labor and project fee, usually between $70,000 and $150,000 per airframe. You take zero inventory risk. You do not need to finance multi-million-dollar airplanes, and your net margins sit comfortably around 20%. The downside is that you capture none of the massive equity upside when harvested parts are sold into the open market. The third model is the speculative asset acquisition and USM trading model. This is where the headline-making fortunes are made and lost. You deploy your own capital or secure heavy debt facilities to buy retired aircraft outright from leasing companies. You manage the teardown, oversee the cleaning, testing, and recertification of thousands of individual rotables, and sell those parts through your own brokerage desk to airlines worldwide. Your gross margins can exceed 40%, but you carry immense inventory risk, extreme capital intensity, and the direct liability of managing depreciating aviation assets. The fourth model is heavy metal recycling and materials recovery. This is the tail end of the supply chain. Once all high-value electronics, engines, and actuators are stripped, you take industrial shears and diamond wire saws to the empty aluminum fuselage and carbon fiber structures. You separate aviation-grade 2024 and 7075 aluminum alloys, titanium fasteners, and high-temp nickel alloys, selling them to industrial metal smelters. This is a pure commodity volume play with razor-thin net margins of 5 to 8%, heavily dependent on global scrap metal pricing and freight logistics. Regardless of which model you choose, the fundamental operating logic of an aircraft part-out facility comes down to a precise mathematical process. You acquire a retired airframe. You deregister it and purge its toxic fluids. You harvest the highest-yielding components within 48 hours. You send those components through certified inspection and recertification channels. You sell the flight-ready inventory into the global MRO ecosystem, and you scrap the bare shell. If you strip this entire business down to the single most critical financial engine, it all revolves around one metric: engine green time and LLP life remaining. In commercial aviation, the airframe, the metal fuselage, wings, and cabin is almost an afterthought in the valuation of a retired jet. Between 70 and 85% of the entire financial value of a retired airliner sits exclusively inside its two jet engines. Everything else, the avionics, the auxiliary power unit, the landing gear, shipsets, and the flight control surfaces makes up the remaining 15 to 30%. An aircraft engine does not just have value because it runs. It has value based on how many flight cycles and flight hours remain before its internal life-limited parts, or LLPs, reach their mandatory legal retirement limit. If an engine has 3,000 cycles of green time left before it requires a mandatory $5 million shop visit, an airline will pay millions of dollars for that engine today simply to bolt it onto an active plane, burn through those 3,000 cycles, and avoid overhauling their own engine. To see how this math plays out in the real world, let us walk through the economics of a real teardown acquisition involving a 22-year-old narrow-body Boeing 737-800, powered by two CFM 567B engines. Let us say you purchase this retired 737-800 from a major aircraft leasing company for an all-cash price of $3,200,000. Your fixed operating overhead to run your facility for the month, including airport runway access lease, hangar rent, ground support equipment depreciation, debt service, certified A&P mechanics, quality assurance inspectors, and specialized insurance sits flat at $160,000. Now let us look at your variable direct costs to dismantle, inspect, recertify, and market this specific aircraft. Towing and defueling cost $10,000. The physical teardown labor to pull the engine's landing gear and 700 individual line replaceable units takes 3 weeks and costs $45,000. Chemical disposal, Skydrol hydraulic fluid drainage, and hazmat remediation cost $15,000. Packaging, specialized engine, stand leasing, and freight logistics to move components to testing labs cost $30,000. Third-party FAA testing, NDT non-destructive inspection, and recertification tagging for the harvested components cost $70,000. Add those variable costs together, and you have invested $3,370,000 in direct capital into this single project. Now, let us examine Scenario A, the clean records transaction. Your mechanics pull the two CFM 567B engines. The technical records team reviews the historical logbooks and confirms an unbroken, pristine back-to-birth paper trail with 1,500 cycles of green time remaining on the high-pressure turbine disks. You sell both engines to an overseas carrier within 45 days for $1,400,000 each, generating $2,800,000 immediately. Next, you harvest the auxiliary power unit, or APU, from the tail of the plane. It passes testing with clean burn hours and sells for $160,000. You pull the complete landing gear, ships at the nose and main gear and sell them to an MRO facility facing a lease return overhaul for $350,000. Your avionics technicians remove the flight management computers, weather radar, TCAS processors, and primary flight displays from the cockpit, generating $280,000 in total sales. You strip the flap actuators, thrust reversers, and rudder controls from the wings and tail, bringing in another $175,000. Finally, you sell the stripped aluminum airframe to a regional recycler for $35,000. Add up your total gross revenue from that single airframe, $3,800,000. Subtract your purchase price, your variable teardown costs, and your 1-month allocation of facility fixed overhead, and your net operating profit on this single aircraft is $430,000 in less than 90 days. That is a return on invested capital of over 12% on a single transaction, which you can turn around and roll into your next airframe acquisition. Now, let us look at Scenario B, the missing paperwork nightmare. You bought the exact same aircraft for the exact same $3,200,000. The plane is sitting on your ramp. Your mechanics pull the engines and begin inspecting the technical logbooks. During the audit, your quality assurance manager discovers that 8 years ago, when the aircraft was leased to a regional operator in an emerging market, a high-pressure compressor disc inside engine number 1 underwent an unrecorded maintenance event where a non-OEM serial numbered blade was installed without proper FAA or EASA trace documentation. In the aviation world, an engine with missing or suspect back-to-birth records on a single life-limited part cannot legally be installed on any commercial airliner registered in North America, Europe, or most major aviation jurisdictions. Just like that, engine number 1 cannot be sold as a complete, serviceable engine. It is legally dead. Instead of selling that engine for $1,400,000, you are forced to part it out for its non-critical static cases and scrap the turbine core, realizing only $400,000 in total recovery value. Your total revenue from the aircraft instantly collapses from $3,800,000 down to $2,800,000. Your direct costs and fixed facility allocation remain completely unchanged at $3,370,000. You did not make $430,000. You just lost $570,000 on a single airplane. The physical metal sitting on your tarmac did not change by one single atom, but because a few pieces of paper were missing from a 3-ring binder, your company took a $500,000 loss out of pocket. In the aircraft boneyard business, you are not trading airplanes. You are trading certified documentation backed by physical metal. So the question that should be sitting in the back of your mind is, what does it actually take to get into this business and set up a facility capable of handling these assets legally in 2026? The barriers to entry are immense, beginning with site selection. You cannot operate an aircraft boneyard on standard industrial land. You need direct access to an active, load-bearing runway measuring at least 8,000 feet in length and 150 feet in width, capable of landing fully loaded wide-body aircraft like Boeing 777s or Airbus A330s. This generally limits your location to decommissioned military air bases, municipal regional airports with excess acreage, or dedicated aerospace logistics parks. Furthermore, geography is everything. If you set up your boneyard in a humid, coastal environment like Florida or Southeast Asia, the salt-laden air and high relative humidity will cause rapid galvanic corrosion on exposed airframes and rot the sensitive copper wiring inside avionics bays within months. This is why the world's premier aircraft boneyards are concentrated in ultra-arid desert climates like Mojave and Victorville in California, Marana in Arizona, Teruel in Spain, and Alice Springs in Australia. These locations offer less than 15% ambient humidity, alkaline soil conditions, and expansive flat ground, allowing planes to sit outdoors for years with minimal structural degradation. The second hurdle is the environmental and hazardous materials regulatory framework. An airliner is filled with lethal chemicals. Every teardown requires draining hundreds of gallons of skydrol, an aggressive toxic organophosphate hydraulic fluid that melts, paint, destroys standard plastic seals, and burns human skin on contact. You must manage jet A fuel residual sumps, de-icing glycols, halon fire suppression gases, beryllium copper bushings, radioactive avionics tubes, and chromium-based anti-corrosion coatings. To operate legally, your facility must install specialized industrial wash pads with underground oil-water separators, closed-loop fluid recovery systems, and obtain extensive permits from the Environmental Protection Agency, state clean water boards, and local air quality management districts. If you spill 500 gallons of hydraulic fluid into an unsealed desert aquifer, the cleanup costs and regulatory fines will shut your operation down permanently. The third hurdle is aerospace certification and quality management. You cannot simply sell an aircraft part on the open market like a used car fender. To sell parts to FAA-certified airlines and MROs, your facility must achieve accreditation under the Aviation Suppliers Association, ASA, 100 standard, maintain an FAA Part 145 repair station certificate, and hold diamond-level certification from the Aircraft Fleet Recycling Association, or AFRA. This requires maintaining an exhaustive quality management system, climate-controlled warehousing for avionics, calibrated tool tracking, and employing licensed A&P mechanics and FAA-certified repairmen who sign their names and license numbers to every single teardown task. To see what this capital investment looks like from the ground up, let us construct a realistic startup budget for a mid-sized, dedicated aircraft teardown and USM storage facility, established in 2026. Securing a long-term lease on 40 acres of airport land with direct taxiway and runway access, including the engineering and paving of a reinforced 20-aircraft concrete parking apron, will require $1,400,000 up front. Constructing a 30,000 square foot, Part 145 teardown hangar, and a 20,000 square foot climate-controlled, secure parts warehouse with high-density vertical racking will cost $3,800,000. Ground support equipment is a massive capital outlay. You need heavy-duty aircraft pushback tugs, mobile diesel hydraulic power units, specialized engine removal lifting slings and gantry systems, 5-ton mobile shop cranes, diamond wire fuselage cutting rigs, and 200 calibrated engine transport stands, running you approximately $2,100,000. Environmental infrastructure, including industrial drainage interceptors, hazardous chemical storage bunkers, closed-loop fluid evacuation pumps, and EPA-compliant systems, will require $750,000. Quality certifications, FAA Part 145 licensing, ASA 100 auditing, legal counsel for aircraft deregistration treaties like the Cape Town Convention, and initial jewelers, block, and aviation hangar keepers liability insurance retainers will cost $450,000. Enterprise resource planning and inventory tracking software specialized for aerospace rotables such as quantum control or component control, integrated with global part trading networks like ILS and PartSpace, will require $200,000. Seed capital to acquire your first 2 retired narrow-body aircraft outright so your facility has active inventory to tear down, recertify, and market on day 1 will require a minimum cash commitment of $6 million. Finally, you must maintain an operational cash reserve. You need at least 6 to 9 months of fixed overhead and payroll in the bank to pay your engineers, mechanics, and sales reps while your harvested components make their way through inspection labs and 60-day airline payment cycles. That means keeping roughly $1,500,000 in liquid working capital. Add every single line item together, and your total capital required to launch a competitive, fully certified aircraft, Boneyard and part-out facility in 2026 stands at $16,200,000. So what does the revenue and profitability reality check look like once your facility is fully operational? A mature independent teardown facility dismantling 12 to 20 narrow-body airliners per year typically generates between $35 million and $60 million in gross annual revenues across USM part sales, teardown service contracts, and component leasing. Because harvested parts carry high gross margins once the airframe cost is absorbed, an efficiently managed operation delivers net profit margins of 12 to 18%. Translating to $4 million to $9 million in net annual profit for the ownership group. To understand how you survive at this level, You have to look at the contrast between a massive publicly traded aerospace giant and an independent operator. Industry leaders like AAR Corp. Or GA Telesis operate on an immense global scale. They have long-term flight hour maintenance contracts with entire national airlines, their own dedicated air cargo fleets, and proprietary component repair shops across 5 continents. They can afford to buy entire fleets of 50 retired airliners in a single transaction, warehousing thousands of parts for years until market prices hit their peak. An independent Boneyard cannot compete on raw balance sheet size, but where an independent operator wins is on execution speed, asset specialization, and low overhead. While a corporate giant takes 3 months to navigate corporate bureaucracy to approve an aircraft purchase, an independent owner can inspect an airplane in Europe or Latin America, verify the engine, technical records in 48 hours, wire the funds, and have the plane landing on their desert runway the following week. Independent operators thrive by focusing on specific high-demand engine types like the CFM56, 5B and 7B, or the V2000. 500 building deep personal relationships with Tier 2 airlines, cargo operators, and regional MROs who need fast turnaround times, customized payment terms, and direct access to decision makers. However, the risk factors in this industry are brutal, and any one of them can wipe out your operation if you lose operational discipline. The most dangerous risk is the counterfeit and bogus parts trap. The global aviation supply chain has been rocked in recent years by scandals involving unauthorized distributors forging FAA 8,130 to 3 certification tags and selling unairworthy components to commercial operators. If your facility inadvertently buys or sells an undocumented life-limited part that makes its way onto a commercial airliner and causes an in-flight engine failure, the civil liability, legal investigations, and reputational destruction will wipe out your company overnight. Your quality assurance protocols cannot simply be good. They must be fanatical, employing forensic metallurgy, microscopic serial number verification, and direct airline audit trails. The second risk is asset depreciation and market overhang. Aviation values move in aggressive cycles. If a major aircraft manufacturer suddenly resolves its delivery logjams and floods the market with thousands of brand-new, fuel-efficient narrow-bodies, airlines will rapidly retire their older fleets simultaneously. When that happens, the market for older USM parts becomes saturated with excess supply, and the market value of the engine sitting in your warehouse can drop by 30 to 40% in less than 6 months, leaving you holding severely devalued inventory financed with expensive debt. The third risk is capital lockup and long inventory holding cycles. While engines and landing gears sell quickly, hundreds of smaller components like passenger cabin doors, wing fairings, and overhead bins can sit on your warehouse shelves for 2 to 4 years before a buyer emerges. If you allocate too much of your cash into slow-moving airframe parts and fail to turn over your capital, your facility will suffer a liquidity crunch while surrounded by millions of dollars of physical metal. So, what is the final verdict? Should you actually open an aircraft boneyard and part-out facility? This business is absolutely not suited for general scrap metal dealers, passive real estate investors, or casual aviation enthusiasts who simply love airplanes. It is strictly suited for seasoned aerospace executives, ex-airline fleet managers, and sophisticated commodities financiers who possess deep technical knowledge of FAA airworthiness directives, direct access to global airline procurement officers, and the balance sheet strength to deploy tens of millions of dollars into high-stakes asset transactions. If you do not have at least $15 million in liquid capital and debt facilities, if you cannot read an engine shop visit report and detect an uncertified compressor blade from 20 pages of technical logs, and if you do not understand how to navigate the complex environmental laws governing hazardous industrial solvents, you should stay far away from this industry. However, if you possess the capital, the uncompromising regulatory discipline, and the operational precision to turn massive retired airliners into certified, high-velocity aerospace components, an aircraft boneyard is one of the most profitable, highly defensible, and structurally critical businesses in modern transportation. Just remember, in the world of commercial aircraft teardowns, the desert may be where retired airplanes go to die, but absolute technical traceability and relentless engine velocity are the only things that will keep your business alive.